right, folks, welcome back to the channel. And this is my part 2 reaction to the NVIDIA keynote from 2024 of this year. Again, I know I'm late to the party, but this has just been on my queue for a while. I wanted to give a good reaction. Part 1 I already dropped. This is part 2 because the keynote is basically an hour and 50 minutes, give or take. We're not going to go through the whole second. In this part, we're not going to go through the whole second half of the keynote. I'm just going to talk about certain aspects of it, certain things that stand out to me from what I've seen. And so let's dive into it.
Nikola Tesla invented an AC generator. We invented an AI generator. The AC generator generated electrons. NVIDIA's AI generator generates tokens. Both of these things.
So I did catch this part, I guess, through some clips or something like that. So what he's saying here is that NVIDIA in itself is much more than a company that creates GPUs and things like that. They're a company that is created. They're a company that's essentially becoming an AI factory. So they could create language models or LLMs on different aspects of the industry. You're talking about robotics, manufacturing, things like that. So they have the tools to manufacture different AIs. All right, so we're going to continue on.
Have large market opportunities. It's completely fungible in almost every industry. And that's why it's a new industrial revolution. We have now a new factory producing a new commodity for every industry that is of extraordinary value. And the methodology for doing this is quite scalable. And the methodology of doing this is quite repeatable. Notice how quickly so many different AI models, generative AI models, are being invented, literally daily. Every single industry is now piling on. For the very first time, the IT industry, which is $3 trillion, $3 trillion IT industry, is about to create something that can directly serve $100 trillion of industry. No longer just an instrument for information storage or data processing, but a factory for generating intelligence for every industry. This is going to be a manufacturing industry, not a manufacturing industry of computers, but using the computers in manufacturing. This has never happened before. Quite an extraordinary thing. What started with accelerated computing, led to AI, led to generative AI, and now an industrial revolution. Now, the impact to our industry is also quite significant. Of course, we could create a new commodity, a new product we call.
Now, just to piggyback on what he said, we're definitely in I want to say an exciting time right now. We're seeing different generative AI solutions pop up left and right. Will those different, I guess, products, will they survive the coming year? Well, will they survive in general? I don't know, but we've heard this in the media before. People are scared AI will take their jobs. In my opinion, yes, but we're far from that where AI could take somebody's job. What's gonna happen is that we're gonna start seeing people look for other people who know how to use AI. We're probably gonna see maybe open AI certification, maybe. but where I think most companies are going to start looking for people that know how to use AI and kind of say, hey, how can how can let's say, I'm applying for a position or whatever, or if I'm going to a company to offer my services, most likely they're going to say, hey, how can we automate this repetitive task? Such and such is getting up there in age, and we want to kind of take this repetitive task and supercharge it. What AI tools can we use, and how can we secure our documents, and how can we secure our information? That's what is going to be valuable in the coming year. Um, Companies are going to look for people who know how to use AI and so forth and so forth. Let's see what else. So right now we're definitely in what is called the fourth industrial revolution. I believe I mentioned that in the first half of this review, but right now we're in an exciting time right now where a lot of things are possible with generative AI. Um, you know, it's the I think the imagination is limitless. There's no limits to what you could create with generative AI. I see a lot of other solutions popping up that's built on AI and open AI. I think automation is going to kick in pretty soon, and we're talking about heavy automation. But let's continue.
Tokens for many industries, but the impact to ours is also quite profound. For the very first time, as I was saying earlier, in 60 years, every single layer of computing has been changed. From CPUs, general purpose computing, to accelerated GPU computing, where the computer needs instructions, now computers process LLMs, large language models, AI
Yep.
models. And whereas the computing model of the past is retrieval based, almost every time you touch your phone, some pre-recorded text or pre-recorded image or pre-recorded video is retrieved for you and recomposed based on a recommender system to present it to you based on your habits. But in the future, your computer will generate as much as possible, retrieve only what's necessary. And the reason for that is because generated data requires less energy to go fetch information. Generated data also is more contextually relevant. It will encode knowledge, it will encode your understanding of you, and instead of get that information for me or get that file for me, you just say, ask me for an answer. And instead of a tool, instead of your computer being a tool that we use.
So again, just piggybacking on what he's saying, I know a very critical update is coming to iPhones. So Apple's keynote that they just recently did, I think we're about a month in right now. They did their keynote. They basically said a big update will be coming where it they're gonna link ChatGPT into Siri, and Siri is gonna get a whole new makeover. Um, because Siri in itself, the history of Siri, it was basically just an app that Apple bought, and with OpenAI's generative AI and GPU computing power, they're now going to tie OpenAI on the back end, and then Siri is going to become more of an AI assistant on your phone. Everybody is kind of up and up about it, but I don't think I don't think it's that big of a deal, because Siri in itself needed overhaul, and I think this overhaul, linking it with Chat GPT, is definitely a big game changer. It now makes Siri an actual AI assistant, because pretty much all you have to do is just ask Siri a question, and it just searches the web for a general answer. But now Siri gets that generative capabilities. I believe it's now going to be able to. I now believe it's going to be able to kind of just you're going to get more interaction out of Siri than you did before this update. So I'm definitely happy to see it pushed down, and I think Apple now kind of just redefines itself as one of those AI definitely companies that stepped into the AI arena. And I'm definitely looking forward to that update, seeing what we could actually do now with Siri, that now it's tied in with Chat GPT on the back end. So let's continue.
The computer will now generate skills. It performs tasks. And instead of an industry that is producing software, which was a revolutionary idea in the early 90s. Remember, the idea that Microsoft created for packaging software revolutionized the PC industry. Without packaged software, what would we use the PC to do? It drove this industry. And now we have a new factory, a new computer. And what we will run on top of this is a new type of software. And we call it NIMS, NVIDIA Inference Microservices. Now, what happens is the NIM runs inside this factory. And this NIM is a pre-trained model. It's an AI. Well, this AI is, of course, quite complex in itself. But the computing stack that runs AIs are insanely complex. When you go and use ChatGPT, underneath their stack is a whole bunch of software. Underneath that prompt is a ton of software. And it's incredibly complex because the models are large, billions to trillions of parameters. It doesn't run on just one computer, it runs on multiple computers. It has to distribute the workload across multiple GPUs, tensor parallelism, pipeline parallelism, data parallelism, all kinds of parallelism, expert parallelism, all kinds of parallelism, distributing the workload across multiple GPUs, processing it as fast as possible, because if you're in a factory, if you run a factory, your throughput directly correlates to your revenues. Your throughput directly correlates to quality of service, and your throughput directly correlates to the number of people who can use your service. We are now in a world where data center throughput, utilization is vitally important. It was important in the past, but not vitally important. It was important in the past, but people don't measure it. Today, every parameter is measured. Start time, uptime, utilization, throughput, idle time, you name it. Because it's a factory. When something is a factory, its operations directly correlate to the financial performance of the company. And so we realized that this is incredibly complex for most companies to do. So what we did was we created this AI in a box, and it contains an incredible amount of software. Inside this container is CUDA, cuDNN, TensorRT.
So before we jump into what he's talking about, we're eventually going to see, for those people in the corporate world, you go through your performance review every so often. We're definitely going to see AI kind of just doing a review of that performance review. It's probably far away. They're probably going to try to block it as much as possible, but we're eventually going to see AI kind of looking at your performance review and dictating if you're going to get a raise or not, or dictate if you get a promotion or not. So again, but this goes back to what I always say. You could either, you have to get the skills for this digital age. You could either fix the robot or be replaced by the robot. So that's up to you. All right, so let's continue on.
Triton for inference services. It is cloud native so that you could auto scale in a Kubernetes environment. It has management services and hooks so that you can monitor your AIs. It has common APIs, standard APIs, so that you could literally chat with this box. You download this NIM, and you can talk to it. So long as you have CUDA on your computer, which is now, of course, everywhere. It's in every cloud, available from every computer maker. It is available in hundreds of millions of PCs. When you download this, you have an AI, and you can chat with it like ChatGPT. All of the software is now integrated. 400 dependencies, all integrated into one. We tested this NIM, each one of these pre-trained models, against our entire install base that's in the cloud, all the different versions of Pascal and Amperes and Hoppers and all kinds of different versions. I even forget some. NIMS, incredible invention. This is one of my favorites. And of course,
So I'm definitely looking forward to kind of seeing what we could do with these NIMS is what Jensen is calling it. Definitely something I think we're gonna eventually start seeing, like everybody has like their own AI, or every machine, that every laptop that comes out now, Microsoft Surface now has Copilot, the Copilot neural engine chip that's on it, basically giving you more computing power at the lesser the cost. So I'm definitely looking forward to kind of interacting with this NIMS and seeing what can be done with it, and what it could basically do, to be honest.
of course, as you know, we now have the ability to create large language models and pre-trained models of all kinds. And we have all of these various versions, whether it's language-based or vision-based or imaging-based, or we have versions that are available for healthcare, digital biology. We have versions that are digital humans that I'll talk to you about. And the way you use this, just come to ai.nvidia.com. And today we just posted up in Hugging Face the Llama 3 NIM, fully optimized. It's available there for you to try. And you can even take it with you. It's available to you for free. And so you could run it in the cloud, run it in any cloud. You could download this container, put it into your own data center, and you could host it, make it available for your customers. We have, as I mentioned, all kinds of different domains. Physics, some of it is for semantic retrieval called RAGs, vision languages, all kinds of different languages. And the way that you use it is connecting these microservices into large applications. One of the most important applications in the coming future, of course, is customer service agents. Customer service agents are necessary in just about every single industry. It represents trillions of dollars.
So this screen right here, definitely a very important screen to look at, because we're seeing how you could tie in multiple NIMs to do various aspects of the whole what's the word I'm looking for, the whole digital chain. Now let's say, perfect example, it's pretty much called IVR. Like whenever you call up whatever, your local provider, whatever, you go through what's called an IVR. Now, sometimes that IVR is actually done correctly, or sometimes you go to a point in a menu where it just drops. So what I'm looking at with this chart for customer support or customer service, all of that is going to be eventually replaced with a different chain of NIMs. So this would definitely be good for healthcare, for elderly people. They don't have to go through that messy IVR type of situation. They could just talk to somebody. They could, well, not talk to somebody. They could talk to a NIM, and basically, if that NIM is configured correctly, it could provide the customer, there's a speech NIM behind it, there's a audio NIMS connected to a speech NIM, and then it's connected to an agent's connected to a LLM of a specific industry, give or take. And then from there, you could just chain, from what I'm looking at, you could just chain multiple things together, and then to give a more humanistic approach to customer service. Because at the end of the day, this is definitely vital for a lot of the elderly, people with certain certain conditions. So this is definitely interesting to look at. I like what I'm seeing here. You just looking at this, you have tons of possibilities for customer service agents, actual agents that don't sleep. If you configure them correctly, then yeah, this is definitely something good.
Of customer service around the world, nurses are customer service agents in some ways. Some of them are non-prescription or non-diagnostics based nurses are essentially customer service. Customer service for retail, for quick service foods, financial services, insurance, just tens and tens of millions of customer service.
Exactly. So you could talk to a customer service NIMS, and then from there, let's say if you're at a bank and it's after hours, you probably I'm just spitballing, so I'm just saying, okay, after hours you need to fill some kind of something happen with your bank. You could talk to a customer service NIMS, and then that NIMS already has the pre-trained protocols on the back end. You could just stop payment on something, or let's say if you're in some kind of emergency room type of hospital, and that hospital needs your medical information, instead of waiting for your doctor or your primary care hospital, that NIMS on the back end could just pull your information and provide all the necessary information to whatever 911, or if there's some type of ambulance service or whatever. The possibilities are endless. I'm just spitballing. So, but if I'm understanding what he's saying correctly, we've, again, going back to what I was saying, we're still at a young stage where AI could take people's jobs, but if you have the skill set to put together a NIMS, like I guess a NIMS chain, to where the person on the front end doesn't know that they're talking to AI, that skill is definitely needed.
Can now be augmented by language models and augmented by AI. And so these boxes that you see are basically NIMS. Some of the NIMS are reasoning agents. Given a task, figure out what the mission is, break it down into a plan. Some of the NIMS retrieve information. Some of the NIMS might go and do search. Some of the NIMS might use a tool like co-op that I was talking about earlier. It could use a tool that could be running on SAP. And so it has to learn a particular language called ABAP. Maybe some NIMS have to do SQL queries. And so all of these NIMS are experts that are now assembled as a team. So what's happening? The application layer has been changed. What used to be applications written with instructions are now applications that are assembling teams of AIs. Very few people know how to write programs. Almost everybody knows how to break down a problem and assemble teams. Every company, I believe, in the future will have a large collection of NIMS, and you would bring down the experts that you want. You connect them into a team, and you don't even have to figure out exactly how to connect them. You just give the mission to an agent, to a NIM to figure out who to break the tasks down and who to give it to. And that central, the lead.
I think, again, me just thinking out loud, I think definitely the IRS should be looking into AI, because we know that there's not enough IRS agents. There's a lot of, I believe, young agents, but not enough of them have the proper skill set to know what to look for. But definitely, I would say, I don't know. I think this would be something for the IRS to look into. Again, auditing reasons, stuff like that. I don't know what they use on the back end, but definitely I know that they're definitely behind on the times. So
Leader of the application, if you will, the leader of the team would break down the task
all right,
and
so
give it to
I'm
the
gonna
various team
skip
members.
this
The
part
team members
because,
would perform
again,
their
this is a
task.
long keynote.
Are endless.
Using the scans you took of your current kitchen with your phone,
They will be AI interior designers, helping generate beautiful, photorealistic suggestions and sourcing the materials and furniture.
we have generated several design options for you to choose from.
They'll also be AI customer service agents, making the interaction more engaging and personalized. Or
I know that would definitely be helpful for a lot of big buildings. You got a 24/7 doorman. You could just replace that with an AI. That person will be there 24/7, greet greet potential guests. That AI agent could just basically say, you could walk up to the agent and say, "Hey, I'm here to see such and such in apartment, whatever." The AI will basically just, with some pre-programming, just ring the apartment. The person picks up and say, the AI says, "Hey, I have guest XYZ here for you. Would you like me to let them pass and go up?" And that person would just say, "Yeah, let them pass and come up." And that's it. Just
digital healthcare workers who will check on patients, providing timely, personalized care.
I did forget to mention to the doctor that I am allergic to penicillin. Is it still okay to take the medication?
The antibiotics you've been prescribed, ciprofloxacin and metronidazole, don't contain penicillin, so it's perfectly safe for you to take them.
And they'll even be AI brand ambassadors, setting the next marketing and advertising trends.
Hi, I'm Ima, Japan's first virtual model.
New breakthroughs in generative AI and computer graphics let digital humans see, understand, and interact with us in human-like ways.
From what I can see, it looks like you're in some kind of recording or production setup.
The foundation of digital humans are AI models built on multilingual speech recognition and synthesis, and LLMs that understand and generate conversation.
as a gamer myself, again, this is going to be game changer for NPCs, non-playable characters. I mean, the branching stories it's definitely going to be endless. I think this is going to take video games definitely to the next level. Hey, I don't know what to say.
我们有丰富的祭祀仪式和传统舞蹈，还有对大自然的崇拜。
The AIs connect to another generative AI to dynamically animate a lifelike 3D mesh of a face. And finally, AI models that reproduce lifelike appearances, enabling real-time path-traced subsurface scattering to simulate the way light penetrates the skin, scatters, and exits at various points, giving skin its soft and translucent appearance. NVIDIA ACE is a suite of digital human technologies packaged as easy-to-deploy, fully optimized microservices or NIMs Developers can integrate ACE NIMs into their existing frameworks, engines, and digital human experiences. Nemotron SLM and LLM NIMs to understand our intent and orchestrate other models. Riva Speech NIMs for interactive speech and translation. Audio to face and gesture NIMs for facial and body animation. And Omniverse RTX with DLSS for neural rendering of skin and hair. ACE NIMs run on NVIDIA GDN, a global network of NVIDIA accelerated infrastructure that delivers low latency digital human processing to over 100 regions. 好吗？
All right, so I'm just going to fast forward just a little bit. And let's see. Because definitely this is a long keynote. Okay. Let's see. I'll leave a link to the original keynote in the description below. But again, definitely for the subscribers, please like, share, and subscribe. I'm going to leave all my links below. If you got a comment on what you want me to do a reaction on, just leave it in the comment. I read all the comments and I do answer all of them. So just say something and I'll leave all the necessary links in the show notes in the description below.
There's more than one model being trained or something happening in the data center at all times, and their noise and their traffic could get into each other and causes jitter. And so when the noise of one model training causes the last arrival to end up too late, it really slows down the training. Well, overall, remember, you have built a $5 billion or $3 billion data center, and you're using this for training. If the network utilization was 40% lower, and as a result, the training time was 20% longer, the $5 billion data center is effectively like a $6 billion data center. So the cost is incredible. The cost impact is quite high. Ethernet with Spectrum-X basically allows us to improve the performance so much that the network is basically free. And so this is really quite an achievement. We have a whole pipeline of Ethernet products behind us. This is Spectrum X800. It is 51.2 terabits per second and 256 radix. The next one coming is 512 radix, is 1 year from now, 512 radix, and that's called Spectrum X800 Ultra, and the one after that is X1600. But the important idea is this. X800 is designed for tens of thousands of GPUs. X800 Ultra is designed for hundreds of thousands of GPUs. And X1600 is designed for millions of GPUs. The days of millions of GPU data centers are coming. And
so I understand what he's talking about here, but let me give you some context. So right now in most data centers, I don't want to say all, I'm just saying in most data centers, you have a mixture of basically CPU servers. Some data centers, you have a mixture of both CPU and GPUs. But what he's saying now with what's on the screen behind him, he's saying you could have with that new, I guess, throughput solution, what he has, you can now have a entirely GPU based data center. For some of you that don't know what data center is, it's pretty much what's the best way to sum it up? Just a football center, a football arena size building with nothing but computers and GPUs in it, some data centers manage network traffic. Some data centers do other things. But you have so much things. I'm probably gonna do a video on the different types of data centers, because that's something like nobody really talks about, and I definitely like data centers. I think we've come a long way in this world where we could have a football size building with nothing but computers running 24/7, 365 days a year, no downtime whatsoever. So, but again, to go back to what he was saying, he's saying we're eventually going to see a GPU size, a GPU only data center. And with those throughputs that he's talking about, this is going to be lightning fast, and it should be able to do a lot of things. But again, there's limitations. There's limitations in power. GPU power consumption is quite high, but that's a topic for a different subject.
The reason for that is very simple. Of course, we want to train much larger models, but very importantly, in the future, almost every interaction you have with the internet or with a computer will likely have a generative AI running in the cloud somewhere. And that generative AI is working with you, interacting with you, generating videos or images or text, or maybe a digital human. And so you're interacting with your computer almost all the time, and there's always a generative AI connected to that. Some of it is on-prem, some of it is on your device, and a lot of it could be in the cloud. These generative AIs will also do a lot of reasoning capability. Instead of just one-shot answers, they might iterate on answers so that it improves the quality of the answer before they give it to you. And so the amount of generation we're going to do in the future is going to be extraordinary.
Skip ahead.
Let's take a look at all of this put together. Now, tonight, this is our first nighttime keynote.
Well, I'm not going to skip yet. So let's just skip ahead just a little bit.
There's a new vibe, okay? There's a new vibe. This is kind of the nighttime keynote vibe. So enjoy this.
Blackwell. Get it, y'all. Let's go.
So, like I was saying before, when Jensen was talking about we're eventually going to see a GPU only data center. So these are all GPUs right here. This is a special GPU. I think it's in this section of the keynote, but where he talks about what this is basically just a giant cabinet of one big, well, I don't want to say one big GPU, but multiple GPUs that are stacked together like servers. But on the back of it, you have some kind of copper spine that runs down the middle. I think he might talk about this here. I'm not sure, but let's continue.
The more you buy, the more you save. With top AI, tailor-made, faster than the speed of light, efficient, best to date， 加速运算，人工智慧，科学创新。
All right, so I'm
now
gonna
you can't
skip
do that on a
ahead.
morning keynote.
All right, let's see what he's saying here.
Actually compatible with all the software that has already been created, your ability to go to market is so much faster. And so the velocity is incredible when we can take advantage of the entire install base of software that's already been created. Well, Blackwell is here. Next year, is Blackwell Ultra. Just as we had H100 and H200, you'll probably see some pretty exciting new generation from us for Blackwell Ultra. Again, pushed to the limits, and the next generation Spectrum switch, as I mentioned. Well, this is the very first time that this next click has been made. And I'm not sure yet whether I'm going to regret this or not. We have code names in our company, and we try to keep them very secret. Oftentimes, most of the employees don't even know. But our next generation platform is called Rubin. The Rubin platform, I'm not going to spend much time on it. I know what's going to happen. You're going to take pictures of it, and you're going to go look at the fine prints, and feel free to do that. So we have the Rubin platform.
So CPUs. So I guess the Rubin platform is what's coming next year after Blackwell. So I'm seeing GPU chips, CPU. That's interesting. NVLink 36 gigabytes per second switch. Interesting. Then you have a Super NIC, 1600 gigabits per second. And what is this? I believe this is something infinite band Ethernet switch. So this is pretty much just all stuff for the GPU data center and things like that. We might see it in the consumer market, but I don't think so. But this part of the keynote is where he talks about what's coming as far as robots.
Perceive the world. They have to, of course, have excellent cognitive capabilities so they can understand us, understand what we asked, and perform the tasks. In the future, robotics is a much more pervasive idea. Of course, when I say robotics, there's a humanoid robotics that's usually the representation of that. But that's not at all true. Everything is going to be robotic. All of the factories will be robotic. The factories will orchestrate robots, and those robots will be building products that are robotic. Robots interacting with robots, building products that are robotic. Well, in order for us to do that, we need to make some breakthroughs.
Hey, so he basically said it, robots building robots and no human interaction whatsoever. So again, going back to what I was saying, you could either fix the robots or be replaced by the robots. But again, we have a long way to go. And but definitely so I'm not gonna do the remaining of the keynote. I'll leave the original link to this keynote in the description, but I think I'm gonna stop it here. So this has been part 2 of my reaction to NVIDIA's keynote, and definitely it's an exciting time. So if you like this, please like, share, and subscribe. And if you want me to do a reaction to something else, just leave it in the just put a note and I'll answer it, and I'll get to it as soon as I can. So I'm gonna stop it here. So I'll see you again another time.